科技与未来。首先呢，我们要请出的这位嘉宾，用他自己的话说呀，如果我不是一位科学家，我一定是一个舞蹈家，因为他从3岁开始就学习传统的印度舞蹈。长大以后呢，转为投身科技界，只因他在科学领域也发现了像舞蹈一般的优雅和创意。那今年我们的年会是未来之舞，特别巧，所以我们也期待看到这位优雅的女性学者是如何把优美的印度舞与抽象的科技舞完美结合的。让我们用热烈的掌声，有请亚马逊 AWS 首席科学家阿尼玛氏阿南库玛女士。
Entrepreneurs in the audience, and I'm very proud to be here. You know, like in China, even in India, there is a strong tradition of the role of women in the society. You know, it's thousands of years old, and women have always been very respected in the society. But at the same time, in the modern world, you know, we have challenges, we have barriers to overcome. And I'm just so happy to see the great work that's being done here to bring the women together and to, you know, increase the diversity, especially in the technology sector, where we have long ways to go. You know, I had strong female role models while growing up. My mother was one of the first engineers in my community and had to, in fact, go on a hunger strike to study engineering because my grandfather, her father, was very worried about women studying engineering, but later on supported her a lot. And through her struggles, through her strides, it's inspired me as well to study engineering, to be always interested about math and computers while growing up. And at the same time, you know, I was also interested in dancing. And, you know, I found that as such a feminine thing to do, very beautiful, very graceful. And I see the same when I'm studying mathematics, when I'm studying this beautiful area of artificial intelligence and machine learning, right? You know, how do we humans learn? And how do we get the machines to do the same? You know, what does intelligence mean to us? Right? Like when we say somebody is intelligent, what does it really mean? And how do we get machines to be the same? How do we get machines to think? These are all some questions that I grapple with a lot. And this field of AI has exploded in the last few years. I never expected when I started studying AI in grad school that it would grow so quickly. And a lot of it has to also do with contributions from China and from Chinese nationals. You know, in my group, I have a lot of students from China. In fact, one of my first students is from China, and now she's also a professor in University of Maryland at College Park. So I'm very proud to interact with students and my friends from China. So now I'd like to, you know, think about what is this future revolution of machine learning and how we can all contribute to this and benefit from this. So I'm also part of Amazon Web Services, and at Amazon there is a long tradition of using machine learning and artificial intelligence. You know, Amazon is a shopping website, so it's natural to think about using AI to do recommendations. So if somebody has bought a tennis ball, most likely they would also be interested in a tennis racket, right? So how do we make such recommendations over such a large number of products, right? I mean, we have just, you know, possibly hundreds of thousands of products. How do we get automated recommendations to all our users that are very relevant? And then the other aspect is in fulfillment centers. You know, Amazon centers are all over the US, and how do we quickly ensure that the product reaches these fulfillment centers, how we manage the supply chain, and how we can quickly deliver to our customers. One of the most exciting recent developments at Amazon has been the Prime Air, or the drone delivery. Right? I witnessed the first drone delivery by Prime Air in the US during an event called Mars that Jeff Bezos had for a select group of individuals. And down the line, we can think about how drones could make it very easy to deliver products to our doorsteps. And then there are the popular products, Alexa, and now more recently, Amazon Go. If you think about Alexa, right, it can be your friend, it can be your contact the user is asking, and then to quickly look up all the related information and answer the question, you need AI, you need strong design of AI into Alexa. A much more recent exciting development has been with Amazon Go. If you go to a store, it can be quite a hassle to go through the cashier, wait for the cashier to bill the products and go out of the store. But what Amazon Go does is it makes you feel like a shoplifter. So seriously, you just pick up anything from the store and you keep walking out, right? And then Amazon Go can figure out what products were purchased. And now this store is open to the public in Seattle. So if you're ever in Seattle, I encourage you to go try out this store. And with this, it can become a lot quicker for all kinds of stores to serve their customers. So I'm part of Amazon Web Services, and that's the cloud division. And there is so many, almost every application you can think of is being run on the cloud, right? So there's a lot of buzz about the cloud. There's a lot of buzz about big data. We have lots of data. Where do we store it? The cloud is the natural candidate. And then the next part is machine learning and artificial intelligence. If we have all the data sitting in the cloud, it becomes natural to process it on the cloud. And that's where building machine learning and artificial intelligence services on the cloud is so crucial. And I'm so happy to be doing that at Amazon Web Services. And indeed, if you think about what is artificial intelligence, a core part of it are the algorithms, right? Algorithms are programs, or saying how we should process the data and turn that into a learning algorithm, and learn from that to come up with a model that can now make new decisions. But to get there, we also need the data. We need the training data, and you need lots of training data. And we also need computing. And that's where having the cloud computing, having hundreds of GPUs, if you want, on the cloud, can be very effective for learning at scale. So when I think of artificial intelligence, there are these three important components: the core algorithms, the training data, and then the compute infrastructure. And all of this can be easily incorporated in the cloud. And so this term deep learning has been very popular now. You probably will hear this term every day in the news, right? It started with computer vision, like how do we understand images, how do we recognize speech, how do we understand text data, and finally self-driving cars, how do we have AI systems even make autonomous decisions on the fly. And this has just been such a big explosion of the use of deep learning across so many domains. And to give you some examples, in computer vision, it's automatically recognizing what are the various objects in an image, right? So here there is the swimming pool, there are all these objects. So automatically tagging that across any possible image that's input to it. And you can also specialize, for instance, with human face, can you come up with a lot of specific information about expressions, demographic information, and so on. And this can be fed into facial recognition algorithms. Can you easily recognize faces amongst thousands in the crowd? How can you do that at scale? These are all applications which we are now seeing every day being applied on the real world. So I just want to give very brief insight into some of my own research that thinks about extending machine learning to many more dimensions. The intuition is the data itself will live in lots of dimensions. For instance, if you think about an image, it has data. And the TensorLee is a library that I've been developing that can do this at scale. So, so that was a brief overview of how we can think about exploiting many dimensions in data. But of course, what I told you about still sounds very complicated, right? And it is, I'm not gonna lie. And what I've shown you here in the screen is like a set of steps one would need to do to take a machine learning algorithm from an idea to one that is scaled into production that could be possibly processing millions of entries per second. So how do we manage this end-to-end process? That's an extremely difficult task, and there are very few experts in the world who can do all parts of this, right? But in Amazon Web Services, we want to make AI accessible to a much larger population. And so what we did was we built SageMaker. And what SageMaker does is make it very easy to take machine learning algorithm from an idea to a production quality code in a few steps. So it makes it a lot easier than traditionally what was being done. Just without going into details, the idea is there are already pre-built algorithms, optimized algorithms that you can access. So you can feed in your data, it automatically trains over as many machines as you want. You could request 100 machines, it will automatically scale to those 100 machines. And it also has sophisticated what we call hyperparameter optimization that can be automatically run to find the best set of parameters. And once a machine learning model is trained, you can also deploy it at scale with just a single click. So the idea is, you have some idea of what machine learning algorithm you want, what kind of task you would like to accomplish. With SageMaker, you can do it at any scale. And that's the beauty of it. So I encourage you to go and try this out and look at very many capabilities that it has. And this is a brief summary of the overall machine learning stack at AWS. At the top level are what are known as application services. So like the example I showed you with computer vision, you want to recognize what's in different images or videos. You want to recognize faces. You can use the recognition app. Similarly, you can work with speech recognition. You can have text processing, all in these application services. So the SageMaker that I showed is a platform service. It's a machine learning platform. So you can bring in your data. You can choose various machine learning algorithms and train with your data to come up with machine learning models. And in the bottom layer, we have the infrastructure, right? So you can go and access as many GPUs you want. We have some of the world's fastest GPUs on the cloud available with the NVIDIA Volta GPUs. So we can have the most sophisticated and fastest infrastructure available for machine learning on the cloud. Thank you. 谢谢.
Thank you. Thank you so much for your professional sharing. Thank you. 谢谢阿南库玛女士的专业分享。 那我们都知道，机器学习呢是人工智能的核心技术，而深度学习呢是机器学习的一种算法。我们知道二位，一位呢是以商业为原点，拥抱科技，而另一位呢是从科研出发，让科学研究的成果应用于各种不同的商业场景。虽然起点不同，但可以说是殊途同归啊。接下来我就想问一个很有意思的问题，也是大家很关心的。你们二位认为人和机器到底是什么关系？我们首先还听听阿南库玛女士。
Could you repeat the last
Okay,
part?
what's the relationships between machine and people?
Yeah, so, it's actually, you really need the help of humans to, to get the machine learning algorithms to work well, right? So there is this concept known as human in the loop learning. The idea is, humans are labeling the training data. So, first you have to tell the algorithm examples of what are the objects in the image. For instance, in the talk, I showed there was a swimming pool. So there needs to be enough examples of what a swimming pool looks like. And then the algorithm can try to generalize, it can learn from it and try to say when there is a swimming pool possible. So the very first thing is humans are needed to label what is present in the images. And then in the other aspect, humans are needed to design the algorithms and to continuously tune it. It's such a delicate process to come up with an algorithm that works well on a range of different scenarios. And so I would say it's still very human-centric to design artificial intelligence algorithms.
Okay. In the future, how does people get along with machine? So do you think... Can you hear it?
Yeah.
Okay. In the future, how does people get along with machine?
I mean, as I said, at the moment, artificial intelligence is still in its infancy, so it's completely guided by the humans. As things will progress, what we'll expect is the artificial intelligence to get much better. It could possibly start learning on its own, right? It can possibly look up new information and then learn from it. And then at that stage, humans can sit back and most of the mundane jobs will be done by AI systems. So I do think then humans can be a lot more creative. They can, spend their energy even dreaming about bigger things, while the AI systems can, make it a lot easier.
好，谢谢。那我们来听听孙总，您怎么看人和机器的关系？你觉得以后将来人和机器怎么相处呢？
I think the machine can be a very good friend to human beings. Before we have a smartphone, I remember when we have to work overtime, we always stay at the desktop to study. And it's very difficult for a woman who have children to balance work and life. Now we have PC, right? You can work anywhere, any places. So that's a great advancement into the technology. And going forward, I think machines can alleviate a lot of repetitive works. We can give these very simple work to the machine and leave more time for us to do more creative arts. Creation, so many more things can be created by human beings if we empower the machine. So I think machine is a friend for human beings.
Helper.
like dancing, for instance.
Yes.
Or embroidery or painting, right? So lots of creative endeavors.
是的，我看到很多数据显示啊，就是今天我们90%的产生的这些数据都是诞生于过去的2年当中的，而且 IBM 也预测呢，到2020年全球的总数据的这个总量呢将会达到35 ZB， 这什么概念呢？1 ZB 啊就是10万亿字节。相当庞大的一个数字。那麦肯锡也预测呢，说未来人类的数据还会以每年40%的速度在不断的增加。那我想请问问二位， 你们如何看待这种爆发式增长的数据以及
and improve the process. And it was a very time-consuming, inefficient way compared to what doctor is doing right now. Right now, you don't need to do any manual survey collection. Instead, their behavior shows the pattern and predicts the future. So I think as we collect more data, our technology advancement will make our daily life more colorful, which will enable us to do more. But of course, much is given, much is expected. Data security will be a key in this process. A lot of engineering power is put into in Amazon, in any IT company.
Okay, how do you think the explosive growth of this data and the security of data?
I mean, indeed, data is central to this current deep learning revolution. Right, so if you look at the algorithms that these deep learning systems are using, they actually go all the way back to 50s, if not earlier. So in terms of algorithms, there is not a significant new advancement. In fact, people in the 80s, researchers in the 80s tried a lot to get these systems to work. And the main reason it wasn't successful back then was that there was no internet. Right? There was not this availability of so many images or so much of text available in one place to get to these algorithms to run. And the other part was the computation. The computers back then were nowhere as powerful as what we have today. And so data is now central to any machine learning algorithm, and in fact central to so many businesses. You know, the entire business model, competitiveness is based on data. And now, as we exponentially increase the collection of data, there is also the question of responsibility, right? If these data is being collected from people around the world, how can we make it secure? And most importantly, what are the fair uses of this data, right? So, the Cambridge Analytica incident that's playing out now, and a lot of media attention on that, I think it's a good thing, because now we can have a conversation of how do we ensure that data gets utilized in appropriate ways. What are the trade-offs between privacy and utility we can think about for the use of data?
我们在探讨机器学习带来的革命的时候啊，我们实际上用一句话可以说，就是机器学习实现了人工智能。那我们知道，阿南库玛女士呢是一直致力于在云上来部署机器学习。那么，您能不能给我们用具体的场景解释一下，哪些行业会受到最大的影响，或者最先受到影响？
I mean, we're already seeing a lot of impact of machine learning in the cloud. At AWS, we have customers from almost every domain, right? So a lot of customers from enterprises, like whether it is online shopping, whether it's healthcare, enterprise software, supply chain, manufacturing, automobiles. Sports, I mean, every possible industry, entertainment, they're all part of the cloud. In fact, so many startups now start out on the cloud, right? That's been the revolution over the last decade, whereas earlier startups had to invest so much in just getting a cluster of machines and then trying to scale up as they got more customers. On the cloud, it has made it so easy. And so I would say almost every domain that you can think of will be impacted and is being impacted through AI on the cloud.
So in your opinion, which industry is going to be influenced the most?
I would not pick one, because almost every industry will be impacted. For instance, when you think about online media like Netflix or Amazon videos, or anything with a lot of video content delivery, right? That data just cannot be stored in any on-premises. It has to be on the cloud because of the scale of the data and in real time. So if I were to pick one, I would pick those ones with very huge amounts of data, such as video data, to be the most impacted.
所以几乎所有的行业产业都会受到巨大的影响和冲击啊。
Yeah, particularly when you go international, right? The cloud enable you to go across the border, so the cloud becomes very helpful when you go international.
谢谢孙总，也谢谢阿南库玛女士，非常感谢。由于时间的原因啊，我们今天这个简短的交流只能到这儿告一段落了。再次感谢二位的精彩分享。Thank you so much for your wonderful sharing.
My
Thank you. 谢谢，请二位落座。